Okay, so now we're going to look at the hypothesis test for correlation. And here's some of the notation. N still represents the number of pairs of sample data. R is the linear correlation coefficient for the sample. And rho, this one right here, rho is the linear correlation coefficient for the population of paired data. So that's for all the paired data. So we have R is going to be a point estimate for rho. So um, the hypothesis. Now the first one, the null hypothesis, is that rho is equal to zero, which means that the linear correlation coefficient for the population is equal to zero, meaning there is no correlation. So that's the null hypothesis. The null hypothesis is rho equals zero. There's no correlation. And the alternative hypothesis that we're going to look at is that there is a correlation, or that rho does not equal zero. There is a linear correlation. So these are going to be the two hypotheses. So now, let's take a look at this example. It says to construct a scatter plot and find the value of the linear correlation coefficient R, and then find the critical values of R from table A6 using a 0.05 significance level. So alpha is equal to 0.05. Determine whether there is sufficient evidence to support the claim of a linear correlation between the two variables. Save your work because the data, blah, blah, blah. Okay, now let's see, 23. We've already looked at this data set and we've already determined that there is a linear correlation. If you remember earlier, we did that up here. We found R to be 0.85 or 0.892 and the p-value to be 0.0005. So we've already found the values that we need for this hypothesis test. The p-value is less than alpha. Alpha is 0.05. So since the p-value is less than alpha, we reject the null hypothesis. And the reason we're rejecting the null hypothesis, the p-value, as you see up here, we've already calculated to be 0.0005. So the p-value is equal to 0.0005, and that p-value is less than alpha, which is 0.05. Whenever the p-value is less than alpha, we reject the null hypothesis. Okay, so that means that since we're rejecting the null hypothesis, there is a linear correlation. The only thing left to do is to construct the scatter plot. So let's go ahead and pull out the TI-83 and turn it back on here. And we want to construct the scatter plot. And here's some directions for the TI on how to construct the scatter plot here. And okay, let's see now. It says to enter the data in list 1 and list 2. We've already done that. We go to stats, we go to edit, and we put L1 the top row and L2 the bottom row there. And then press stats and test. So we're going to get out of here. We're going to quit first. We quit and then we go back to stats and then we go over to tests. And on the test, we're going to go back to linreg-t test. And I think that was E. Yes, linreg-t test is E. And we press enter. And all the information here is correct. L1 is where I put the CO2, and L2 is where I put the temperatures. And the frequency is 1. And as you saw, the null hypothesis for the test, was rho is equal to 0, so the alternative was rho is not equal. Rho is not equal, meaning that there is a linear correlation. So, alright, so now we have all the things we need. The alternative hypothesis, rho is not equal. And then we go to calculate, and we get this. And as you can see here, they give us the t-test statistic, and they give us also the p-value. And once this is inputted into your calculator, now you have a regression equation saved into your calculator. All right. Now, in order to do the scatter plot, what we're going to do is we're going to go to second. We're going to go to y equals, and above y equals we have stat plot. And plot 1 is what we're going to enter. And it's blinking on, so I press enter to turn plot 1 on. And then we're going to select the graph type. So the type of graph is this type, which is just a scatter plot, just all the x's and y's graphed as ordered pairs. So we're going to do a scatter plot. And x list is list 1, y list is list 2, and you can choose what mark you want to make. You can make a box or plus. I'm going to make dots. Let's see. Let's go down here and scroll over to dots. Okay, and then now from here, we're going to go to the zoom, and we're going to go to zoom stat. That's how we're going to see our scatter plot. So zoom stat is number 9, and we press enter. And here are the data values. You see there is an increasing pattern here, and that is the scatter plot. Now, we can also look at how the scatter plot looks in terms of the regression equation. What we do is we press y equals, and it takes us to the functions. And then from y equals, we go to vars, and that's where the variables are. We press enter, and once we press the vars button, it takes us to this screen, and we want number 5, statistics. So scroll down to number 5, press enter. And what we want is we want an equation. We want the regression equation. So EQ is for equation. We're going to scroll over to EQ, highlight EQ, and then we're going to look for the regression equation, number 1, and press enter. So now what it did is it put the regression equation into y for the graph. And when I go back to the graph, I see this is the regression equation for the ordered pairs. Okay, and let's see. So that's the scattered plot, and that's how you put the regression equation into the scatter plot. All right, so let's now take a look. Oh, I guess that's it.